so much. Laba diena visiems. Labai smagu čia būti. I'm from Canada, but from a Lithuanian family, so it's really special to be at the first PyCon, and it also is in my family's ancestral homeland. So it's great to practice Lithuanian, finally get a chance to speak the language outside of just what we talk about at home. So let me get started. Oh, my slides aren't showing. 1 second. Yeah, there we go.
Hey.
Thank you. Yay, awesome. Always fun. That's how we debug at Mozilla. So, good times. Great start. Okay, well, I'll get started then. So today I'm talking to you a little bit about Merino, one of our web services that I work on maintaining. Ironically enough, Mozilla has a culture of reorganizing people frequently between different teams, and I just got swapped to a team that does mostly Rust, so that'll be fun. But anyway, my name is Tadas. I work on the contextual services team for Mozilla. So we maintain a number of services that are intended to provide value to users through suggestions in a privacy-respecting manner. A little bit about me, again, I'm from Canada, currently live in the US. My previous life, I was a professional double bass player in an orchestra, into tea, cooking, nature, cold swimming. So if anyone is a fan of these things too, come talk to me after. All right, so a brief summary of what we'll discuss today. I'll tell you what Merino is, what its architecture and how the application is structured. And within that application, we have a number of suggestion providers, and I will feature one in particular. From there, I'll feature why we selected Python, and tell you a slightly funny story that relates to the earlier sessions today. What dependencies we use, our testing strategy, monitoring, telemetry, and observability. And again, shout out to a phenomenal session earlier today on observability. And then finally, our deployment and rapid release model. So this is intended to essentially be sort of a best practices in how sort of we learned a number of useful lessons in maintaining and developing an application at Mozilla. Because there's core services that are within the browser themselves, right? It's called Mozilla Central. And then everything peripheral to it, like Merino, is an additional service that the browser calls out to externally. This allows us some flexibility in how we structure our architecture so that we're not entirely bloating the browser, because of course we have different considerations than, say, a standard web application. So, development. They said this would be straightforward. Requirements. I think we've all run into this situation where it seems like a plan is well set, guidelines, product is bought in, we're good to go, and things kind of don't quite go as planned. Merino started out as a Rust application, of course, for its speed and maintainability, but the problem was, even though we have a number of very good Rust developers at Mozilla, getting more people to learn Rust and work and maintain a service in Rust was incredibly difficult, and especially for a service that requires fast, iterative development, Rust is not particularly well suited for that. So, I'll show you Merino or Firefox Suggest. So you'll see if you type into the URL bar, I was going to demo it, but I'm not going to mess with the display. Firefox Suggest gives us the ability to show results in the URL bar. Through a number of user research projects, we determined that users really like being able to access a lot of information within the URL quite efficiently. And because Firefox is a core browser, we want to be able to make people's experiences as effective as possible, but also while not being creepy. We have a partnership with Ad Marketplace, which is a less creepy advertising company. They're very good. We have a strong partnership with them, and allows us to share sponsored content based on someone's search query. So you'll see the first result there is Amazon. The second was the Wikipedia provider, which is a partnership where we index Wikipedia's 7,000 most commonly viewed articles, and then suggest those results based on a keyword search. Next is Top Picks, which is the one I'll feature, which is basically the top 1,000 web domains, accommodating for common misspellings and other errors. And then we've got two other ones, the Firefox's extension recommendations engine, and then our weather, AccuWeather. So, I always hate reading architecture diagrams at conferences because it's so hard to see from your perspective, but essentially to walk through it, the user accessing via the Firefox URL bar types in a search query. From there, our Suggest API endpoint will basically take that query to our Suggest request handler, which, depending on which of the providers is enabled and instantiated, will return relevant results. So this also has allowed us to sort of use feature flags and toggle certain features on and off, and also allow opt-in experiments. We do that a lot at Mozilla, where we'll take a very small portion of the population, test out a particular feature, and see how well users are engaging with it, gather a number of metrics on it, and again, it's fully opt-in, as is Mozilla's culture. We kind of don't do that without asking people. So yeah, you'll see we have a number, and then the backends are a little bit different for each of these because we try to store as much of the data that's returned to the user in memory, as opposed to having to access an external database. Because we're dealing with sub 200 millisecond response times, we want to make sure we're very effective. So I always loved this phrase from Star Trek. I'm a big fan. The more they overthink the plumbing, the easier it is to stop up the drain. So this is one of those cases where you try to look for as much simplicity as possible within a particular service, and Merino kind of engaged us with that challenge. So to summarize our requirements for Merino, we needed to have lean data practices and make sure that we could provide data to users with low latency and speed. Of course, automated test coverage and robust test suites to ensure no regressions as we're sort of moving along quickly. Observability to maintain our system health, but to also have some good ideas about if a particular feature or patch that we landed caused problems. Telemetry. And then the last bit, which we actually launched while we were working on Merino, was rapid release and continuous deployment. This was a push for us to have sort of developer-driven deployment strategies, which allowed us to very quickly respond to potential incidents, but also have more control of our deployments. We all love our SRE or DevOps teams, but pretty much everywhere they're inundated and very busy and have tons to do, so it's best that if you can really tee them up for the things that matter. So here's a slight example of a slight data optimization that we're able to do from the Rust version. It looks very simple, but the data structure is simply just converting it from a standard Python dictionary instead into a list where the index point of 1 has a particular index value. This allowed us to sort of improve our algorithmic searching, and I'll get into that a little bit when we look at this specific provider. But instead of having to match all of these different keywords based on what letters were inside of the keys, we're able to more quickly pass through the actual full keyword itself and create a more effective match. This specifically relates to our suggest endpoint and being able to reduce query latency and network calls by offloading queries and putting data in memory. This is sort of when we landed that patch and got a little bit of telemetry results for that. So pretty significant improvement in performance on that end. And then again, a focus on lean data, right? There's always this question of if services need to consume data one way or another, either unsanitized, untrusted data from an external source, or to process data and return it to a user, we need to make sure that access is cheap and that it's compact and efficient, which is often a very difficult thing to do. This meant we had to consider how we would structure the data efficiently, and as I mentioned, making sure that the indices and keyword searches were associated and stored in an effective way. The other thing you'll notice is that we serve small favicons that relate to all of the domains. So that was actually a rather tricky thing to do because we needed to make sure we have some effective association, in addition to the fact that because we are Mozilla and our data practices are what they are, we have to have stored copies within our own individual CDNs to deliver to users. We can't basically just direct or serve untrusted content, essentially. We have very strong rules around that. And then a nice sort of additional feature is that we're able to sort of, through our partners in data science, define common misspellings for particular domains that are searched. It's very easy. A cat jumps on the keyboard, or you just type too fast and you mess up a domain. That's a really nice feature that we're able to basically pull through and implement. And if anyone wants to ask later, I can show you a couple of the configuration changes. If you have Firefox Nightly, if you don't now, I recommend you download it. It has all of our newest features. You can enable Merino there and play around with it yourself. So since we're at a Python conference, briefly highlighting some of the sort of dependencies, libraries, frameworks that we all use. Merino is fundamentally a fast API application. Again, we went from building a Rust Actix Web framework application over to fast API, and the improvements were drastic, honestly, within the first couple of weeks when we started restructuring and not even refactoring. We basically burned the old one down and started with that. Poetry for dependency management, I highly recommend it if you haven't used it. PyProject.toml rocks. No more requirements.txt. I mean, I know you can get into like religious wars with this kind of stuff, but I highly recommend Poetry. It's a great resource. Pydantic, huge shout out to Pydantic. We just upgraded to V2 a couple months ago. It's sort of core. We use typed Python. Because our team uses a lot of Rust and Python, having type safety is a really valuable, important thing. Of course, along with that goes MyPy. For simple linting, we use Flake8, Black, Bandit for security checking. PyTest is our core testing framework, along with some of the other added bonuses that we get from Fast API's test client, for instance, which is really good for asynchronous testing. Apache Airflow, which I'll get into a little bit. We have a couple of external jobs that run to generate the data that we then serve to users. Then there's Elasticsearch, Redis, and GCP. Just had to throw that in there. Duck typing is a very wonderful thing in Python, but it seems like we're kind of moving away from it these days. So I'll briefly get into the structure of our providers. All providers take in a suggestion and they match it against a value. The backends are what actually ingest and create the data in memory so that the application can access it. We have cron jobs that are set to sort of manually, at specified intervals, refresh the data so that we're not having stale info. Now, obviously, for a provider with like the top 1,000 most commonly accessed URLs, we don't need to be updating that every day. That's kind of a useless, pointless thing. So we have a job that runs every 2 weeks, updates the domains, and then the cron job basically runs and makes sure that if it corresponds to the time frame when we're updating the data, it does that. The more deep question with the backends is how can we avoid needless calls and needless network consumption? It's not so much, how fresh can the data be constantly? So what ends up happening a lot of the time when you're trying to add and extend features within a new application is that you will build for one particular architectural plan and then find yourself in a quagmire because you didn't accommodate for that original idea. Knowing this from the Rust version, we approached the providers to be as modular as possible. So that's why we set them up as a defined protocol. We made sure that every single provider would have a matching protocol, which essentially would have a query request. We called them different things for each given provider, but essentially all the provider's doing is accessing information, passing a suggestion request, and receiving data. So I just described this a little bit here, a little bit earlier, but that's essentially how the topics provider works. That's how it will look in your menu bar if you type in IMDb, and once you hit the D, boom, you'll get that small suggestion and result. We also have to sort of categorically rank things based on your browsing history as well, or if you have a favorite, that tends to come in a little bit sooner. So that's just for fun. I haven't seen a better depiction of synchronous versus asynchronous programming ever. That's just mostly for fun, but being able to use suggestion providers that are fully asynchronous like this just make a world of difference. I've worked on a lot of Django applications prior, but yeah, I just love this. All right, we won't have a ton of time to go through the code, honestly, but fundamentally we inherit from Pydantic base models and create basically the data for each of these values. Okay, I'm getting to 5 minutes, so I'm going to move along that a little bit more quickly. Apache Airflow essentially runs a portion of our code within the repository to generate this data. So it will make the network calls necessary to generate and aggregate the data and create a beautiful, fully optimized JSON file that we can then consume in memory and use to construct our backend index. So that's what we use Apache Airflow for. So a little bit about our testing strategy, right? We run into all sorts of issues when you're trying to mock requests, right? Especially when you're mocking external services and third-party integrations. It's very, very hard. So we essentially have a 4-tiered strategy, very standard: unit tests, integration tests, contract tests, and load tests. So our unit tests, again, quite simple. We aim to maintain 98 or greater % test coverage. We use a lot of mocking and monkey patching, and in PyTest, an extensive use of fixtures. Some people have feelings where you can predefine all of your fixtures within a conf test at the root of your directory. Honestly, it really depends on the scenario, right? I kind of personally like to have the fixtures defined within the same module that it's testing, kind of like with Rust's unit tests, right? Basically, whatever works for you is the best approach you want to follow. But nonetheless, fixtures are the sort of most effective, efficient way, I feel, for us to be able to test functional unit tests where we need to access the data internally. Integration tests allow for additional verification between our different service components with a little more opacity. So I mentioned the Fast API test client. We use this to send requests to Merino internally. So again, we just verify responses and make sure the outputs match, as well as we do some log checking. We do some integration testing to basically intercept and verify that if we have errors, that the right errors are propagating and going to Sentry, for instance, or that our telegraph metrics data is being output in the way that we expect as well. Contract tests, which are, slightly less clear, slightly more complicated integration tests, just simply operate at the API HTTP layer. So, okay, and then our load tests, which are very impressive. If you have time to look at them in the repo, you're welcome to. But we use load tests as a gut check to verify that the service can handle the scale that we throw at it, essentially. We have a tag, basically, that triggers the deployment pipeline and also then specifies, so you'll see this little, it might be a little hard to read, load test, abort or warn. We pass that into the merge commit for a pull request, and that will specify to our pipeline whether or not to run these load tests, because we'll basically bundle everything together, send it to Docker Hub. If that's there, the Jenkins pipeline will trigger and set up our load tests, at which point we can monitor them and watch them in staging. So I'll have to go through this quickly, but the key consideration for monitoring is making sure that we respect user privacy above all. This makes monitoring and tracing really, really hard sometimes, right? A lot of the times we need legal review before we can even approach adding a particular bit of tracing data. So I kind of want to posit this, there's lots of great information on monitoring and observability, but more so sort of the questions that we ask. How can we guarantee performance? And do we have sufficient benchmarks that are in place for us to have a sense of confidence in our service, right? So we use statsd and Telegraph. So we have a statsd Telegraph instance within our Kubernetes workflow. So essentially, it's a very easy way for us to use the GCP console to sort of verify the data. And then additionally, we push everything to Grafana and visualize things nicely. Though, who else has used Grafana before? Okay, has it made you want to gouge your eyes out sometimes when you're also trying to figure out, yeah, hit or miss. But it's a great tool. And then Sentry for error reporting as well, of course. So for telemetry, when we think about logs, traces, and metrics, it's a consideration of how we transmit data from a remote source for monitoring. I kind of went over that already. Observability, I'm proud of this picture. I took it myself, just a bunch of Arctic foxes, just watching you. Again, a couple of questions to ask regarding your service, which are ones that were very important for us. How well are things working together? And do we have the data and the tools to interpret the data? That can often be the bigger bottleneck, right? Something like Datadog is phenomenal, but sometimes at scale, given the amount of requests you're using, can be exceedingly expensive to use. So we have to constantly weigh the cost-benefit analysis of how will an experimental service at first provide us with the data that we need to set benchmarks, and then furthermore, when it's operating at scale, how do we then verify the application's stability and also verify that it's not regressing based on sort of changes that we make. All right, so yep, there's just a little snapshot from our Grafana dashboard, API request durations and other bits of data. All right, and then I'll top it off with deployment and rapid release. So this was a more recent initiative that we took because we used to sort of have a defined cadence for deploying the application, which can still work well with Rust apps, but again, at Mozilla, we have a lot of core, Merino's not one of them, but maintaining, say, the push or sync service that's used by millions of users concurrently. When you're doing rapid release, it can get a little scary, obviously, because if you're pushing major changes to production very quickly, you want to be able to fail fast and have some trade-offs. So we used to essentially trigger the deployment, test everything on stage, and then basically unclick and sign off to deploy to prod once we had some additional verification. So again, we push commit to main, and the Circle CI workflow is triggered. So I'll show you this. This is our standard deployment workflow. So every single time you push, we use Circle CI, and we'll eventually actually move to Argo CD on GitHub. But runs a number of automated tests, builds the Docker image, runs the various tests, and does a couple checks. Beyond that, then we have the main workflow, where we do a little bit of additional checking, And then we publish a Docker image of Locust, which is the library we use for load testing. And then if that verifies and passes, then we have some sense of stability. But this is, again, based on those little deployment flags I mentioned to you, either abort or warn. If there's a feature that we have some significant concern about regression, we will usually use abort and not deploy. And then we can dig into our GCP console a little bit, look at some of the logs and tracing, and figure out what may actually be the issue. Parts of this slide didn't load. Okay, let's see. Nice. So anyway, cool. Well, must have been something great, I don't know. Well, a couple final thoughts for you. Decoupling is your friend. You want to decouple components as much as possible and make things as easily extensible as you possibly can. We ran into a couple of growing pains with this. You won't always know once the product requirements are kind of initially set. You'll learn things as you go. But as often as possible, if you can make interfaces and make use of protocols and have a sense of indirection, that will make things so much simpler. Especially, say, if you're switching between AWS or GCP, just that added layer will just make refactoring a lot easier. That kind of goes along with not over-engineering things as well. Fast API is phenomenal. If you haven't looked at it, please do. It's incredibly useful. It's very fast to learn. And also make use of some of the modern Python features that come out with every single release. We're pretty aggressive about making sure we update our Python versions as we go. And that's granted us a lot of really useful. So you'll see things like, the walrus operator scattered throughout our code base, and match statements and everything. Basically, we have an attitude where take advantage of the newest language features as soon as possible. Especially we're looking at things like enums and whatnot, certain design patterns that are a little bit more effective that emulate the benefits of other programming languages. When you handle migrations and updates, do them quickly and do them often. I don't know if anyone else had to deal with the Pydantic v2 upgrade. The features were amazing, but it did take a little bit of doing to upgrade. So kudos to them for doing such a massive overhaul, but it was a bit of a pain. That was my job, so that's why I'm saying that. Developer-driven deployment is great, as is having the help from SRE or DevOps, but I'm sort of a definite advocate at this point of having developers have control over the deployment lifecycle and better insights, because it just allows you to respond more quickly to problems and issues and kind of creates a sense of openness within the engineering culture, and also very much a blameless culture. It's kind of nice, it sucks if you break something or whatever, but it's easier if everybody's equally liable to break everything, right? And everybody understands. So, so everyone's looking after one another, so I highly recommend it as a modality. And observability, finally, is about asking questions, about asking the right questions for your use cases. Who are your users? What is the intended purpose of your application? What are the baseline metrics that you need to understand to know that you can scale when your service receives a lot of requests? So anyway, that concludes the presentation. I really appreciate your time today. Sorry about the snafu at the beginning. Děkuji всем. Čulovaj.
And I have already a question from Ellie about Redis. Are you thinking about switching from Redis given the upcoming license change?
Oh yeah, that's something that came up in a meeting. That's a good question. I'm not 100% sure if we have yet. It was mentioned in one of our Slack channels. We use Redis specifically just for caching our weather suggestions presently. But yes, that is a good reminder and question. That's something definitely worth considering. But yeah, I think so, given the license requirements for me.
Any more live questions?
Yeah, hello. Thank you very much for the presentation.
Thank you.
Insightful. So the first question, actually, I have two, if you don't mind. So the first one is, so you mentioned you're using a fast API. Do you use a private fork of it, or you use the open source version?
We use the open source version.
Open source.
Mm-hmm.
But do you actually contribute anything back?
I'm trying to think if I can see where this question is going. Yeah, no, we've thought about it. I mean, our hands are full sometimes, but yes, it has come up on our minds to actually contribute, given how frequently we use it. Are you a contributor to Fast API yourself?
No.
Okay.
I'm concerned.
You're concerned. Yeah, and that's always something to encourage. A lot of our developers do a lot of open source contributions, and it's a very sort of meaningful, sort of historic part of Mozilla's development culture. So But yeah, maybe that's finally the last encouragement. I need to actually get my hands dirty myself then, right?
Thank you. And the second question, you mentioned that you're using in the project, you're using the customer, the user's browsing data or browser history. How do you use this?
Oh, sorry, the browsing history. So we're not using that for this service. What I meant is that within the URL bar, your browser client will, in conjunction with all of those sort of potentially suggested values, show you frequently visited websites from your history or your bookmarks. So those are two completely segmented services. But yeah, no, you can't even utter the words user data without getting everyone's ears up at legal. But yeah, we're very cautious about that. So those two components are very segmented, but the client code is what aggregates all of it and displays it.
Awesome. Thank you.
Thank you.
I'm wondering how agile is your architecture?
How agile is our architecture? In what way?
Do you change as time goes on, or what I saw is what it to be?
Yeah. Trying to think of the right way to answer that. I mean, are you saying in terms of like new features and things, like when we're dubbing? Yeah, I mean, once we get sort of core components maintained, we have a sort of defined maintenance cadence, but it's tricky because a lot of our development can often be in fits and spurts once we get some data from a particular experiment, which can either show us whether a feature has been successful at engaging users or not. So I guess that can slightly inform it, but we do generally predefine like, a set of core objectives for a particular service, develop them, work against them, and then as sort of things come in, kind of pivot and shift. We're jumping all over the place pretty frequently. I hope that answers that, yeah.
One last question? Yeah.
I have a question. I saw that the deployment process itself includes canary deployments.
Yes.
And in Firefox you have millions of users. Could you share any of the rules that you define where the canary deployment is successful?
Yeah. Yeah, that's a good question. SRE handles more of that specifically, but I'll try to answer it as best as I can. I know we run our load tests explicitly against the stage environment, and then what else we do? I'm afraid I don't have a great answer for that question at the moment, but it's kind of a standard default. But the thing is with Merino is that it's still not implemented and used by the core users of Firefox. It hasn't landed in day-to-day Firefox. It's in nightly still presently. So the canary is kind of maybe a little bit hand-wavy. It's there so that once we get to those points, we have the adequate gut check. But historically, it used to be we would uncheck to deploy from canary. So we'd get a prod canary deploy, run a number of automated tests. Sometimes QA would run some manual testing against it before then we would unhold to production and deploy. But that's something we're likely to kind of shift and change in the future.
Okay, thanks.
Sorry, I can't have a clear answer, but yeah, feel free to add me on LinkedIn. I've got some business cards if anybody wants to chat, but look forward to chatting with more of you throughout the rest of the conference.
Yeah, so let's thank Tadas.